Good evening, ma'am.
Good evening, Kirtana. Have you done the revision of the last class? Today we are continuing with the chapter Thermodynamics. Done the revision of the last class?
Yes, ma'am.
Everything was clear or still having any doubt?
No doubt, ma'am.
No doubt. But in the test, Kirtana, you didn't perform like this because you have no doubt. But in the test, what I found that quite disappointing. Why? Why is it so, Kirtana? May I know?
How
Kirtana?
much did I get in the last test, ma'am?
Solutions I didn't check. Coordination I already told you. I will check your coordination solutions test tomorrow. Then I will let you know the marks. Okay.
Okay.
So let's start with the chapter. The last topic that we have done is we have introduced a relation between CP and CV. Okay. This is our last class.
Yes, ma'am.
Today we will start with reaction enthalpy. Date is 26. That is a reaction enthalpy. Now, what is this reaction enthalpy? Enthalpy, we know that what is enthalpy? We have already discussed now what is enthalpy. Here we have discussed now whatever the amount of heat that a system had at constant pressure, we call it as enthalpy, right? Kirtana? Kirtana, are you there? Kirtana, are you there? Kirtana, are you there? Kirtana, are you there? Kirtana, are you there?
Yes, ma'am.
You have joined from two systems,
No, ma'am, only one. It
but
got disconnected just now.
but here I am getting that you have. Okay, just make your video on.
Yes, ma'am.
Yes, where we were doing about the reaction enthalpy. So thing is that what is enthalpy? We know that whatever the heat a system has at constant pressure, we call them as enthalpy. Okay.
Yes, ma'am.
So what is reaction enthalpy? Basically, when we are doing any reaction like converting a reactant into product, the change in that enthalpy, we call it as a reaction enthalpy. So we can say that it is the change accompanying a reaction. Enthalpy change accompanying a reaction. Can we say this thing? That is reaction enthalpy, right? Or we can say the heat that is present in the system or heat content of any system is my reaction enthalpy. Can I say this thing? Right?
Ma'am, can you explain it again? It got disconnected.
Yeah. Whatever the heat of a system has, we call it as reaction enthalpy. Or it tells me that whether a reaction will happen or not. It decides the spontaneity, it decides whether reaction will happen or not. Clear?
Yes, ma'am.
Now, the thing is that how to represent a reaction enthalpy. Basically, when we are converting a reactant into product, means my enthalpy is changing. So I can say that my reaction enthalpy, R represent for reaction, H is for enthalpy. It is enthalpy of products minus enthalpy of reactant. Okay. And here we have placed stoichiometric coefficients of product minus stoichiometric coefficients of reactant.
Yes, ma'am.
Clear?
Yes, ma'am.
For the example, if I am having a reaction, that is, I have this one. This is getting converted into this one. Okay. So how do I calculate the reaction enthalpy for this one? What I will do, the reaction enthalpy of Kirtan, are you there?
Yes, ma'am.
Why your video is off?
Ma'am, actually, I can't keep my phone on the place. And from tomorrow onwards, I'll join from other device, ma'am, so that I can on the video.
Okay. Like for this reaction, if I have to write a reaction enthalpy, I can write that stoichiometric coefficient of C and enthalpy of C. इसको क्या हो गया अब? Right?
Yes, ma'am.
ये क्या हो गया? It's not working. Or plus coefficient of D, enthalpy of D, minus coefficient A, enthalpy of A, plus B, enthalpy of B. In this way I can write this one.
Yes, ma'am.
Clear? This is my simply reaction enthalpy. Now next term that I came is standard enthalpy of रिएक्शन। एक मिनट, इसको कुछ हो गया है। Now, what is this standard? Basically, when we talk about like when the conditions are in standard state, like 1 molar is there, it is at standard temperature, it is at standard pressure, then I say that my enthalpy of reaction is standard.
Yes, ma'am.
When participating substances are in standard states. Clear?
Yes, ma'am.
Like it should be pure, it should be at 298 Kelvin, it should be at 1 bar. These are the standard conditions. ठीक? Basically, I'm talking about enthalpy of reaction. So we have various phase formations now, like fusion is taking place, vaporization is taking place, melting is taking place, sublimation is taking place, right? So these are also the reactions. So I can say that delta H during phase transformations are different. Means enthalpy changes when there is a phase transformation takes place.
Yes, ma'am.
Okay. If I say that I am having standard enthalpy of fusion, fusion is what? What is fusion? When a solid is changing into liquid or liquid
Yes,
changing
ma'am.
into water, a solid. When a solid changes into liquid, we call this process as fusion. Okay. Next, we have standard enthalpy of vaporization. Vaporization is what? When a liquid changes into gas or vapors, right?
Yes, ma'am.
So at that case, I will say that my standard enthalpy of vaporization is taking place. Next, I have sublimation. In this way, we can have several enthalpies of clear. Right? Now we will discuss one by one. First, we have standard enthalpy of fusion. Are you getting Kirtna? Kirtna, are you there?
Yes, ma'am.
Yeah. So enthalpy of fusion is what? When my ice changes into water, I can say, or I can say it is the melting of 1 mole of solid.
Yes, ma'am.
Okay. So if it is a melting basically, so my I represent the standard enthalpy of fusion by delta H. As it is a fusion, so I will write fuse and standard के लिए हम ऐसे circle बना देते हैं. Clear?
Yes, ma'am.
So we can say enthalpy change that accompanies melting of 1 mole of solid substance. Kirtna, just rejoin again. I'm rejoining it again because this is not working.
Okay, ma'am.
It is not getting.